This is Mayor Richard M. Daley of Chicago. You're watching Campus Housing TV at University of Illinois.
It being the 21st century, we have all these gadgets and gizmos. Everyone's got a cell phone, everyone's got an iPod, all this and that. And you know, when it dies on you and you're out with your friends or whatever, it's always really inconvenient. So wouldn't it be nice if you had just a small, little, rechargeable device? So what we're going to be making today are these little cell phone or iPod chargers out of the Altoids tin. So it's really cute, really MacGyverish, you know, pull it out and, oh look, you know, charge it up in emergencies.
All right. Well, we have the voltage source, which is our wonderful Duracell 9-volt battery. The red line is the output, or where the positive flow comes from. And that goes into our voltage regulator here. And the voltage regulator keeps the voltage at a steady 5 volts. And that voltage regulator supplies the USB port and the LED with power. I'll explain the switch later. And the resistor keeps the LED from burning out because 5 volts is way too much for the LED. Actually, it's the amperage that's way too much, and that slows down the current for the LED. And both the LED, the USB, and the switch are all connected to this black wire. But the switch is what controls what if all the others are connected to the black wire, which is ground. And so this switch allows everything to flow and allows that light to light. It allows power to go through the USB port.
And of course, you know, as how a battery works, you have a bunch of electrons in here. The chemicals are converted to electricity. So you have electrons flowing in here, and they flow, negative charges want to go away from negative and towards the positive. So you have all the electrons flowing towards the anode, which is where all the positive charges are. And it kind of wants to equilibrate it, but when it reaches equilibrium, your battery dies. So when your battery is dead, you can just say, oh look, it's reached equilibrium, and you'll sound really uber nerdy and awesome. There's the LED, and an LED works, it's kind of like it's a diode, so it's like a one-way street with the electrons. Only wants to go one way. You have impurities that are placed upon a semiconducting material, and it's kind of like the cations there grab the electrons and create almost like holes, and they bring down the electrons to a lower energy level. And if you guys remember from Chem 12 114, when you bring the electrons down in energy level, they emit light through photons. Photons are emitted. So it's kind of the basics of this. I'm going to have Charles demonstrate the circuit diagram for this.
Well, I made these circuit diagrams in MS Paint. They're like all over the lounge right now. And basically, they illustrate how simple the circuit is. And two things on this diagram that Beth didn't explain that I'll explain right now are the resistor and the voltage regulator. Basically, the resistor is a very simple device. It's just a chunk of carbon to make the flow of electrons go slower so that the LED doesn't burn out, because at the current voltage level of 5 volts that the voltage regulator outputs, it's too much for the LED, and it'll burn out if we don't have the resistor. So the resistor just is a safety thing for the LED. And the voltage regulator basically will just take the 9 volts from the battery and convert it to 5 volts for the USB port, and it keeps it at a steady 5 volts as much as it can. Because with some voltage sources there can be current spikes and voltage spikes, and it usually will take care of that. And the ways that they can take care of that are through capacitors within the integrated circuit or various transistors. It depends on the voltage regulator. I'm not sure what this one has inside it exactly. So, and then the basic circuit is very simple. It's just like it takes voltage from the battery and it goes into the voltage regulator. The voltage regulator outputs to both the USB port and to the light emitting diode. And it goes through the voltage in pin for the USB port, and it goes out the voltage out pin, obviously. And both the voltage out of the USB and the voltage out of the light emitting diode go to the same conduit, and that is hooked up to a switch. And that switch is what determines whether the light is on or off, because that connects everything to ground, and that lets all the electrons flow. So that's basically how this works.
So we have a 9-volt battery, and if I can get you to hold this up while I write down up here. The lovely Alora.
And her wonderful Hello Kitty jammies.
Okay, so we have a 9-volt battery, but the problem is the LED can only handle 1.8 volts, right? So we're going to need to use Ohm's law for this. What's Ohm's law? That's this triangle right here. VIR. It's a good way to remember it. Switch it around. So what we need to know what kind of a resistor do we need to put in here if we didn't already have one included. Well, if you look up here, we see that R is right here, so V all over I. This is your voltage, this is your current. And we know that we have the 5 volts already because we had the regulator take it down, the 9-volt battery down to 5 volts. Now we have 5 volts, so okay. How can we move 5 volts down to 1.8 volts? So at 1.8. And now for the current, we have 0.02 amps. That's something that you'd have to be given. So we were given this value, and then that gives you the resistor that we have. So that's how you determine the resistance, what kind of resistor you need to use, and that's included in here. And now I'm going to have Alora demonstrate some more engineering principles for you guys. There's that.
Okay. Well, for the integrated circuit, what we're using, like the resistor, like he was talking about, I got a couple equations offline about it going into the 5 volts, and it shows the relation with the resistance. So I'll write them up here, but they're big and confusing. I will warn you. And this marker is big and confusing, so hang on. Can you yeah. So there's 2 of them, so I'm gonna mark it 1. It shows the relationship between because the other equation, these 2 equations show the relationship between the resistance, and it shows how, I guess it helps it's the equations to regulate the flow of electricity and voltage. So.
Do you know what all the letters stand for?
I actually do not.
They're all letters of the alphabet.
Because I know when I was looking them up, I didn't write them down on my sheet. So, yeah. But
It's okay, we forgive.
And this is supposed to be the triode region, and this is the saturation region.
Okay.
Okay?
Sweet.
And so that's for the integrated circuit. And then for the snap connector, it shows this equation will show the relationship between the voltage out and the voltage in and how you can determine it. So this one's a simple one. So we have, I'm going to just, V naught is going to be V out. And this is voltage in.
Okay, I am Jason. This is my first year here, and I am majoring in electrical and mechanical engineering.
I'm Charles Hughes. I'm a junior at UIC, and my major is computer engineering.
My name is Travis Strutzenberg. I'm a mechanical engineer, and I'm a freshman at UIC.
My name is Keith Weber. I'm a computer engineer. I'm a freshman.
You've got the resistors, you've got the LED. This is your toggle switch that turns it on or off. What else do we have in here? This is the battery clip. And all your stuff's in there.
That's awesome.
And so when we spoke about, you weren't here for, we gave like a little introduction about basically relating this project to engineering, talking about some of the equations behind it, some difficulties you have. Because in engineering you do a lot of problem solving. So one problem with this project is you have a 9-volt battery, but
I chose computer engineering because I wanted to be involved in the sciences, and mainly because chemistry and physics seem way too hard for me, and computers and designing systems and programs is really fun for me.
I chose my major because my uncle's an engineer and my dad is a mechanic, so I kind of figured I'd combine the best of both worlds. And I know a lot about cars, I know a lot about the mechanics of cars, so I figured that would help me out. And I've always been good at math and physics and all those subjects, so it was a natural choice.
I picked my major because I like hardware for computers, and that's electrical engineering, but I also kind of like putting computers together and putting some basic programming together, and that's more software, and computer engineering is the merging of both software and electrical engineering, so it was a natural fit.
Electrical engineering is more stuff that you can't really see. Mechanical engineering is all logical. It's stuff that you can understand just by looking at the world, whereas electrical engineering is stuff that you more have to understand.
Wait a second. Are we gonna set off the fire alarms?
Oh yeah, that's
No.
No, not with this.
I've done this in like a very confined room where there were alarms. This was in Commons West, and they didn't set them off.
Alarms.
Yeah.
We don't need no fire alarms up here.
that one?
Yeah, we don't even have heat.
And if they go off, we'll just say we didn't start the fire.
We'd have to sing it.
We didn't light it, but we sure did light it.
How do you get a home?
You want to see it work?
Utility thing right here.
So here's the iPod, the cable that comes with every iPod,
On the
right?
back side of your pliers, do you have like a pair of wire
Insert.
cutters, like sharp blades? Because that'll do way better to cut those tins.
Oh wait, I
And
do.
then over here,
I'm almost positive you
We're
do it
gonna
on the back
wanna
side of the
turn it on.
pliers. Like on the very end, there should be a pair of like wire cutters or so.
I have scissors.
Even those would probably work better than just hacking
so
away.
it's kind of hard to get this in here. It is homemade.
It'll probably break on.
Look, turned on.
Break it. I'm not gonna.
Yeah, cool.
See
Watch.
how-
I'll turn it.
see
See
how
the
easily that
LEDs
was?
showing that it's working. It's okay. I'm done charging it. Turn it
That
off.
part of it's the least
And you
necessary.
see at the top how it stopped charging.
Because the battery's
Isn't that nice? It's convenient, right?
Yeah.
And this is all in this little itty bitty tin. So
So cool.
yeah. And then look, I want to charge again. Oh, what's up?
Here's my
It's charging, baby.
Nice.
This is your USB. Put like it right here and just kind of like trace around it. Sorry, I'm gonna grab this pencil. Sorry.
How'd I like what?
Go ahead and trace it, and then you're gonna like
Okay,
cut
be
it
very
out.
careful because that isn't like a curve, and you will like.
Do you have it on low?
Well, I don't know if it is where.
Let me see.
It's on low.
Yeah, it's on low.
We should be
Let's
fine.
just
It's not gonna
practice
go anywhere.
safety.
Just be very, very careful.
You're just saying that because you don't want to get in trouble. if
I know
someone
on the
kills
cameras.
themselves.
Be very careful.
Blood spray against the glass, which is not good.
That would quench anyone's bloodlust.
So many things are there.
The cutter
with your thing.
and twist it.
I'm so close to
The
getting
box
it.
cutter.
Yeah, the box cutter, and then just twist it.
Just because we got to get some practice, like soldering wires together and just like getting real practical use out of like circuitry. It was cool.
Well, I was just helping with like helping the kids assemble the project because I understood how it worked and I could draw the circuit diagram in a few different ways, so I thought I'd just be helpful. The way I actually soldered it together was kind of weird. I used the case as a ground and as like a way to connect wires. It was a quicker way, not necessarily simple.
I was just kind of told to show up that day, but I signed up for it because I'm like, this would be so cool. My MP3 player's battery is constantly dying. I need to replace it. So I thought this would be kind of cool to do, and I signed up for it and then forgot about it. And then they called me and I'm like, oh, oops.
I'm trying to find the best way. I don't want to lose my finger.
Okay.
I'll hold this here and you'll apply the solder.
We don't have voltmeters. What are we doing?
Yeah, I have my voltmeter.
Oh, there it is. I'm like
It's a
looking
program
around.
that
I'm like,
Beth,
my
put
gosh.
together. It's really cool.
And this thing awesome.
I've seen off.
That is cute.
Isn't it? It's a cute little thing, right? It's nice.
No, because nobody responded to my email, and
He's like,
I
why
guess
do you call
nobody is
everything
willing
cute?
to take the day from me, unfortunately.
All right, what do I solder
Yeah,
this
Saturday
to?
night, especially.
I'm not the soldering guy.
I don't know. I'm sorry.
I'm the drill guy.
So soldering,
Yeah.
if you, do you need to start soldering?
Yeah.
Okay, cool.
But what do I solder?
We'll take your pieces. The soldering iron's over here, so you gotta go over there.
I take
So
all my
Charles,
pieces?
yeah, take all your pieces with you.
No, it's
and go
fine.
over there with
I know
Charles,
more
and he's
people-
gonna help you with the soldering
Yeah, that's
aspect
cool.
of this.
I mean, I know more
Okay.
people want to go.
Same
So.
as that. The middle one is what? Positive, negative, out,
Yeah, the middle one is out,
which is
which is the 5 voltage, which supplies the power to the USB and to the LED.
okay. Positive or negative? It has to be one or the other.
Thank you.
Or just tell me
Technically,
which the short.
technically it's negative, but electricians think of it as positive
I
because
know. I
that
got
can.
raped on that EC
Okay.
bastard. Benjamin Franklin.
I will explain that to everyone.
Damn him and
Yeah, and what's it called? Because Americans are so arrogant. We believe that or electricity flows positive,
It technically does.
positive and negative. It's with it's the electrons that move though.
Negative flow one way is the same as positive flow the other way.
It's true. It's true. But why are we have to be so different?
Why are we stripping wire?
Because it was
That's what I wanna
convention
know. Why is he
when,
stripping wire?
when
I'm not really
electronics
sure.
started, so it's
All of my
convention
stuff
now,
is stuck
just
together
so
without any
electricians
wire
don't
being
get
stripped.
confused.
So I wanna know.
Everywhere else in the world
doing
is the other
something
way.
different. I don't know.
So how is that convention if we're the minority?
We are the majority here
That's all that matters.
Why are you stripping wire?
We are having.
because we use wire.
Mine didn't use any wire, Keith.
Not yet.
We're going to use wire.
Yeah, we're going to use wire. I was just special, and I decided I wanted a piece of green here.
Keith is special.
That's
What
all
does
that.
Keith
that-
Keith just wants to be green, okay?
I like green.
But it's not easy.
How you like purple?
Exactly.
But there is no purple
It ain't
wire.
easy being green.
Oh yeah, there is some purple. But that's ugly purple.
Okay, where's the solder? You get to solder this.
Okay, so which one is it?
I'm done now.
Short lead or long lead?
Long lead.
Let's go.
A guy I know who goes to Milwaukee School of Engineering, he made this thing for his door that it's got like a keypad on the outside, and it wires up to the inside. It's like this big long Lego contraption that opens the door for him, because he doesn't like having to carry his keys around. So you can just punch in the number, and then the little Lego arm opens the door from the other side.
I made a lot of fun little projects with my dad. Like my dad and me drew basically all kinds of stuff together, all kinds of science projects, and me and him fabricate a lot of our own fun tools. And one time before, we had to make a mousetrap car, and instead of making it out of like wood and making it really lame like everybody else is doing, we made it out of stainless steel because I love Back to the Future. So I had to make a DeLorean out of stainless steel. It was ridiculously cool, and I got a ton of extra credit because I showed up in a white jumpsuit like Doc. It was really, really fun. But just little fun projects like that happen all the time at my house. So I have soldered before. I have done a lot of that kind of stuff before. I've never really worked with the USB ports or the voltage regulator, stuff like that, so that was a new experience. But a lot of the other stuff, it was really just first time making it all come together into a really cool little charging project. It was fun.
Nothing like chargers, but a lot of soldering project like LED strobe light, shock box, radio tuner, voltmeter, Van de Graaff machine, 3D LED pyramid, 3D flasher, the agitator, and a bunch more that I can't remember offhand.
We'll just put it like that.
Insulate the whole inside. It's a trap.
Okay. Bring it on, little.
Yes,
I do.
Do I start doing this? I don't know what I'm doing.
Where's your go?
Keep making holes.
It's okay, this is a difficult one.
What up
Show you how
now? What
it's
up
done.
now?
Good job. Oh, job.
No.
Try to get out of that one.
Okay, look up.
I don't know what this is.
Scissors are on this side.
This in your other hand?
Second one on that side.
Or, no, you hold
So
it
pull
like
the first one out. Now hold the
Yay.
So it's like a pencil?
That's easier to manipulate.
Makes everything easier, kind of.
Well, let's see.
Just in a...
That was a good noise.
He like flipped the thing around. Like, almost.
Did
You
you
might wanna
did you
move
grab
that.
it?
Why isn't that on a stand?
Oh,
There's the stand.
There's only 2 stands out.
yeah. There is no stand for this one.
Oh, okay.
Oh, that's great.
Didn't see that one in the mess of wires.
You alright, Heath?
Yeah, that's fine.
Where you burnt? You need some ice or anything?
No.
There's
Actually,
an
it's not
ice over
bubble.
there. Not yet.
I would offer you some
That's what I
gum,
was
but
gonna
I ate
say.
it all.
All right. Well,
That was more scary than painful. Because I'm like,
I'm
time
gonna
to
get
put
a tin
this.
for that.
You're melting the paint.
It's the shocking factor.
Oh, I thought you just fell. I'm like, oh my god.
Soldering irons are really hot and they give you 3rd-degree burns. Yeah, I was the one who screamed. Not only did I hit it once, but then I went away and touched the other one with this one. Actually, 3rd-degree burns, it just kind of decayed, just dead. So then there was just a hole there, which was kind of a good thing because there wasn't that painful bubble. It was just kind of an open wound, and it's just like, I've never seen that happen before. Because soldering irons usually have a lot of lead on them. I had to clean that out right away. Usually for electrical circuits that we use, it's 60% lead and 40% tin. And then the center of the solder is a rosin core, which when it melts, the rosin melts first, goes onto the solder or the board and evaporates, cleaning the metal so that the solder goes on there and makes a really strong physical and electrical connection. Don't lick it. Wash your hands after you're done using it. If you get burned, clean it out right away because you don't want, it's lead, that's poisonous. So take any precautions of like if you have an open cut and you're using bleach, make sure you have it covered.
Keith, you just make everything look like a disaster. Look at how nice his is, and look at what you've done to this thing. It looks like
Well, that's because
piece of art.
Charles is doing
It
my-
looks beautiful.
I go through later and I trim off all the extra.
Okay, well that's a good idea.
Well, that's just my stuff.
For attention, but that boy knows what he's doing.
You know,
There is a deeper, significant meaning to the structure of that. Do you know what it tells me?
It's made by a
That it was made by
Winter's
Keith?
Morning. That should be its title.
Winter's morning.
It looks like a satellite dish.
Looks like an antenna.
Like, you know, or you
You're
know
not
how I'm
gonna
talking about,
see
like, where
the
they put the
wires.
coat
Why do they have
hangers
to
on
look
top?
pretty?
Yeah. Because I can't exactly.
Okay,
look
so
at,
what do you think
it
you
all
tested
fits
the
in there. There's no
resistor?
room for anything else.
The most difficult part, I think, was both soldering the really small areas. Like you, in one point, you had to solder wires to the outside prongs of the USB, and it was like a very, very, very small area. So you had to be careful not to like solder across too. And it was something I hadn't done before. I'm used to soldering like big open areas, like under the hood of a car or something like that. But that was really difficult. And then getting everything to fit in the little altoid tins like that big, it was ridiculous because you had like 8 feet of wire or something crazy. It was just really hard. So you had to like mold it around, and it turned out really good. I would probably choose something a bit larger to put it all in. Perhaps something like maybe, I can't even think of something bigger, like a Spam can or something like that. I make it out of a Spam can. I could use a bigger battery or something. Something fun like that, but altoid tin was just too small.
One thing that was difficult for me was actually letting the kids build their own devices because I found that I was just like doing everything for them. And after a while I realized what I was doing, so I just like guide them and tell them what to do and just help them while they're doing it.
The low end resistors that we got, which are like a 30% tolerance, burn out really easy. Normally resistors don't have like a thermal wear or tear unit. They can heat up to just extremely hot, and then usually the solder melts before the resistor does, but for some reason the resistor went out before the solder did. But that was something new that I've never seen before. It basically works except for the LED doesn't turn on, so you don't know when it's on or not. That's the only problem. So I just have to take out the resistor, put a new one in, and then the LED will, basically when you turn on the switch, it turns on the LED that says it's on. Well, right now without that resistor, because that one's burnt out, the LED doesn't go on even though the circuit's on. So you don't know if it's on or off. That's the whole purpose behind the resistor.
Ali, can I see Allison?
What? Not all
Can I
birds
see
are
Allison?
pigeons.
Angela?
Angela.
That's really bad British
I don't know, it starts with
Oh
an
my
A.
god.
You named your pliers that you rip people's teeth out with?
Yeah.
You've ripped people's teeth out with
haven't
No, he
done it
threatens
yet.
them. He threatens them to rip their teeth. Shut up! I'll rip your teeth out. What?
Gosh, I'm gonna scoot away from this.
I know, you missed
So
out.
anyway, just picture.
I only do it against people who threaten
It's
my
like-
life.
it's-
I'm
You
not
don't threaten your
gonna
life,
hurt
you
you.
threaten
Let
your
me see.
safety.
Oh, there we
Why
go.
don't you just carry pepper spray?
I'm like,
Because it's more fun.
More manly to
rip someone's tooth out. Yeah.
Because that means you have to get close enough to do
Wait,
it.
what was the player's name again?
Angela.
Angela.
I like the name because it
See
sounds
that
like
with
Angel.
Angela. Exactly.
Those are yin and yang.
Like, I could probably help clean it up, but
I should probably cut it more.
you might want to take, like, kind of make it semi-rectangular rather than, like, you just shot at it with.
Let's see, let's move it down for you, actually. Let's move it.
I'm not exactly sure what happened to mine, but it doesn't work anymore. I was using it the night I made it, and then it just stopped working. And I checked all the connections and everything looked good. I don't know, maybe something just heated up too much and it broke. I don't know.
All in all, it was just something cool to do. I don't even have like an iPod or anything that could possibly charge from it. The closest thing I have is my Rio MP3 player, but I've yet to try it on there yet. But I think it was just a really cool project that I didn't want to miss out on.
I definitely want to redo the Altoid thing. I burnt out my resistor on it because I held the soldering iron on it a little bit too long. And resistors don't usually burn out when you put that much heat, but this one did. So I had to go back and redo this one, but I just love making little projects and hiding them in little containers because I just think that's the neatest thing in the world.
You can plug in your iPod, cell phone, whatever it can charge with a USB port into this, and it'll charge up as long as the battery's charged.
Band-Aid plastic bandage and collar. Hurt elbow. Band-Aid bandage. It's blue. Hurt ankle. Band-Aid bandage. It's yellow. It's red!
I gotta tell you.